how much energy do you generate in a day without even knowing? Simple, mindless tasks that you do throughout your daily life, like walking through a room, opening a door, or filing through papers. These are all ways that you are passively generating energy without even knowing it.
What would happen if you were to harness this energy and turn it into something usable in home or office? How much of an impact could you make just by going on to your daily life? Magnet is a device that transforms the simple action of closing and opening doors.
By moving magnets through a copper coil, we can take advantage of the principle of electromagnetism to harness energy. That means that you have ready to use, ready to store, and ready to share renewable energy made just by you.
Thanks to magnetism, you can generate 1 watt in a minute. That's 60 watts an hour, which can power some of your home appliances.
The system is universal and scalable to multiple setups, including desk drawers, office break rooms, and even kitchen cabinets. With frequent use, you can generate enough of your own energy to coach your current program. All this just from a single cell.
Magnetism, opening the door to renewable energy.
So, at Magmentum, we wanted to address the needs statement, NSO8, which was to design and produce a prototype that can capture and use energy generated through the home and office. To do this, we first had to work through a process. We had to identify existing renewable and passive energy sources, find ways to harness that energy in our lives, then brainstorm ideas to harness that energy, compare different concepts so that we knew we were choosing the right one, and decide on which idea or prototype that we wanted to market. With that, we looked at what you generate as passive energy. Every day, you unknowingly open doors, walk through halls and rooms, and fidget at desks. What would happen if we harness that energy inside of our homes and offices? To do this, though, we need to think of the requirements for our device. We have to make sure that it is easy to use. We have to make sure it's efficient, cheap to produce, that it is applicable to home and office spaces, and that it is modular in design. With this, we came up with initial design concepts. We have power bank shoes that generate power as you walk, rerouting energy with a smart power strip, vibration energy through passive means that would take passive tasks and use them to turn into energy.
We came to a simple final solution, which is a small passive device that generates power from the most common household and office actions, which was Magmentum, which was a small box that would harness kinetic energy from opening a door, utilizing electromagnetic technology that would be applied to home and office spaces.
So to go into a little bit of the science behind why this actually works. So there's a couple prototypes that are being passed out right now of these energy cells, which I'll be talking about. So if you think about a door as it opens, if you think of the outermost point, that's a lot of like momentum and energy that's being created right along like the radius of where the door opens. So our idea was to make these energy cells, these kinetic energy cells that get mounted on the door, so that when the door gets moved back and forth, the little brass balls inside of it upset this whole system. These magnets go back and forth between the copper wires, and then we harness the energy caused from the magnetic field there. And again, the springs just kind of further encourage oscillation in the system and just kind of capture the most energy that we can out of the movement. Next slide. So we did a couple motion analysis to figure out the best possible spot of where we should put this, and we decided the top corner of the door right there. You can't really get to it very well, it won't restrict the movement. And if you see, the fuel cells will be lined up right there, so it's moving back and forth, and the energy is captured the most right there. And this is just another animation of how this would work. You can see that there's only the magnet and the spring on one side, just to kind of simplify the animation, but if you see the ball comes over, hits it, upsets the system, there would be two on either side, so it would just kind of be vibrating back and forth and oscillating. And here's a little more specifics behind the math and the science behind it. We have a couple of graphs here of the displacement of the system corresponding to the voltage that's created, again, as the brass ball passes back and forth between the wires. And it all kind of comes back to some very basic physics problems, but it's just using that in a way to harness energy.
So this right here is a breakdown of our system. So we went ahead and made the box transparent so you can see that they're going to end up being at least 4 of these fuel cells lined up and held down by this bracket piece right here. You can see the magnets here, the brass balls here, springs there, and you can even see the copper wires right there. So this is going to ideally be bolted to any door, and as you move it, that's what's going to make your energy. Next slide. So it's mainly 3 pieces that you're going to have, but there's of course more attached to this middle piece right here. You put it in, you lock it down with those screws, and then just attach it to the door. Next. So these are pictures of the things that we passed out to you. They are prototype models made with FDM and SLA printers. And you see the brackets right here broken apart. You have the tube right here, which is more accurate to the size that we want. And you have the caps here with representations of the spring, magnet, and ball. And of course the casing here. So next. And this right here is going to be a more closely realized version of what we intend to bring to the world. So this has our logo on the side. Fit it all together. That's what it's going to look like.
Hi. After the physical prototype, we look into a little bit more in the circuit and see what the estimate of our current or how we build the circuit, how it actually will work. We assume for 180 millivolt input, and we use a 60 ohm resistor. With this, using calculation and estimation, we aim for 2.16 milliwatt for 4 cells in around 20 seconds. Thus, this is 1 watt in 100 seconds for the whole box. And we were looking for an LED light that can need 18 watts to work, which means our box will need to generate around 20-30 minutes able to have that to work. And this is our cost analyst. This is the list of all our material combined and detail. And luckily our cost in total is only $8, and we're looking for a profit margin at 21 cents.
We feel extremely confident in the price point that we set for this product because we do believe that the Magmentum box has several different benefits that we divided into primary and secondary. First of which is that it is a low cost. It's low cost to manufacture. It's a small product, it's compact, and it has a simple concept, which means that it's easy to troubleshoot and easy for the end user to kind of repair if they need to do something like that, as well as modular. If one cell happens to need some fixing, you don't have to replace the entire Magmentum box. Secondary benefits include supporting low-income energy generation for low-income communities all across the globe, as well as low electricity impact if there are individuals that are interested in plugging out of the power grid and plugging into renewable energy. For our future developments, we do hope to improve the design to include a capacitor, just because we know a capacitor is something that can help regulate current within the circuit. Additionally, we would also like to expand to have the Magmentum box be usable on several different door types, such as cabinets, desk drawers, and closets, as well as inclusion in high traffic areas like stadium doors, mall doors, restaurant doors. The possibilities are endless with Magmentum. And finally, what is the impact of this device? Our needs statement asks us to capture renewable energy and remove the reliance on macro level policy decisions as a driver for change. When you invest in Magmentum, you're putting change back into the hands of the individual. You're taking the first step, or rather the first swing, into a world where slashing your carbon footprint is just the norm. Here are our references. And we are Magmentum, opening doors to renewable energy and closing doors to carbon emissions.
All right, thank you, Magmentum. Judges, once again, they were addressing need statement number 8. In case you didn't catch that, we'll go ahead and open it up for 5 minutes for questions from the judges on their product.
Yes.
So in this modular system, I saw that you had a prototype with some wires. So So you're feeding into some capacitor system?
Ideally, yes.
That's in the house. So did you provide any cost or feasibility on that in the presentation? I wasn't sure if I saw that.
Well, we will look into it at the next step. Since its capacity is helping in the system to a stable current, it does not necessarily like create electric current in the system. Since the ball moving and the door open time to time, so sometimes if the door is not open, the capacitor will help keep the current flowing that support a certain power output that we need.
And then this is something that an average home doesn't have, right?
Right.
It doesn't have an energy collector. So, but that's another part of your system, right?
Yes.
Okay, yeah, so the cost analysis that we had was only for this, box right there, the whole assembly. We don't have any of the routing wired in because, again, it can be applied to anything from the doors of Corvette to the kitchen cabinets. So it just depends on the system.
Yeah, the battery size can change, capacitor quality can change, just depending on where it's placed, how many people, and what else.
Yeah, I have 2 questions.
Okay.
So you stick this thing on someone's bedroom door, so the balls are, and that's not gonna annoy people?
Well, it's
So
not necessarily a bedroom door, it's anywhere that's high traffic.
Yeah, I was thinking I'd make a great sitcom.
Yeah.
They start yelling,
I don't think they'll be necessarily
trying
always
to
be.
build energy. The other thing, how do you get the energy out of this stuff? That wasn't clear.
One thing we had in mind was we were planning to put a small power bank in with the design, so it's easy to attach and put back in. So at a certain amount, the whole system will charge the power bank, and then we take that out and then we replace with a new power bank.
But again, this all goes through wires, we can move the power bank, we can hardwire it into something else. That's what makes it so universal, is that as long as we're getting power, we can move it to anywhere we need it, whether we need to store it or we need it to directly power something.
But as far as like the theory behind like how it works, it's the science and math behind that has actually already been tested and researched. We're just applying it to this system.
Remind me of something else. Do you guys get paid out of your $20? If you look at your slide, you're just charging for materials.
We haven't
That would be
estimated.
something we would think about further. Right now, it's just the design concept and the device itself.
And those would rely a lot on looking at like the
So
manufacturing of it.
nobody gets paid for something.
So this analysis is just for the box. We would have to do a bigger one, but again, that would depend on the manufacturing, the facilities, the labor. There's just a lot that goes into that, but just for this box itself. This is just an estimate of what it would be.
I guess this is, if you just said the total material cost is $878, I wouldn't have noticed when it was when you had the profit margin. That made me think, well, it's getting paid for the simple.
Did you mention alternate designs or different materials that would be considered for this?
Yes, one alternate design, as I mentioned earlier, is the capacitor and the small power bank into it. We also can link up to like the doors. You can see the automatic door stopper. They all sometimes they have already connected to the electrical system. We can also utilize that and connect to that system.
As far as overall design though, just having 4 in one box, it could be more or it could be less. If say we're at like a heavier size door or more people go through like a bigger door, then we can have more of these. The design can change that way. As far as materials go, I think as long as we have like the outer casing and the piece that holds the actual cells together, I think if that's non-magnetic as well as the casing of the cells, I think that's gonna help us out. But again, there's so many possibilities that we're only seeing more and more of the more that we're here with this project. So it's almost going to be limitless as time goes on. There's no telling what we can do. It's just as matter as we can get it there. Because it obviously works. It's been researched before, so we're confident that it's going to
Yes, you have a
be
question?
probable.
This will be the last question.
Yes.
Yes.
So, a couple of things. One of them is, how do you know when you already got into the limitation of this? So in other words, what is the limitation of your device? And then once when you already have the energy there, so have you thought, guys, on a monitoring system in there that will give you information and then discharge that or save it somewhere else? Like there was a question on that.
Yes, to answer your question, is one limitation is how unstable the ball moving inside the tube, and there are four of them, and the moment in inertia will move unstably, which is hard to measure. That's why we're thinking about letting it open out easy to form internet, and the capacitor for the current stability. And sorry, what's your
The
second?
monitoring, how do you know when this one is already full of energy and that's it, is not capturing more than the limitation of the device?
Yes, we thought a little about that. Like we were planning to put the LED light on side system that's parallel to the capacitor. When the capacitor is run out of energy, the LED will shut off or turn on, depends on how we want to design it. And that will, we can see the little LED on like all the capacity run out. That will help us.
Another protocol to that is that we can end up having either this LED or an LCD display that ends up telling us, oh, if the cells are bad, you just open it up, place in a new cell, put it back in, you're done.
Did you take a class with, about the, not names, but about the energy harvesting with a professor? How do you know about this technology and this? I know that he did.
I think I just read and work on a bit energy harvesting, so
Yeah. It's his graduate research.
Mm-hmm.
So.
All right, thank you for